In this example, we are asked to compute the integral of the square root of 1 minus x squared minus 3 quantity squared. The way I do this is I'll try to sketch the graph of this function. So to do the graph of the function, I'll just write y equals the expression here. And I'm going to square both sides so I could get rid of the square root. But I'll remind myself that y has to be greater or equal to 0 because the square root of something is always positive, maybe 0. Okay? So I'll just remind myself, write that to tell myself that it is. Y is positive, so y squared is 1 minus x minus 3 quantity squared. And I'll move this over to this side to get x minus 3 quantity squared plus y squared equals 1. This is an equation of a circle, the center 3, 0 and radius 1. But knowing that y has to be greater than 0, we'll see what that means. Okay, center is 1, 2, 3, 0, and radius is 1, so I'm going to go 1 up, 1 over, 1 to the left. I would have gone 1 to the down, but they told me that this is a positive square root, so I know that y should be greater than 0, so I won't go below the x-axis. So this is then my graph, 1 minus x minus 3 squared. So this is the graph. Now they want the integral of this function, meaning they want the area under the curve up to the x-axis. This is a half of a circle of radius 1. So it's 1/2 of pi r squared. So this is equal to pi over 2. And that's the final answer.